Okay guys, in this video lesson we're going to take off from our idea of velocity and start moving on to this idea of acceleration, or how do we figure out the acceleration of a sphere or an object as it moves in a circle. Okay, so if we go back to what we talked about before, we know that our accelerations and our velocities and our forces, nothing has really changed. Those fundamental things still exist, but now we just need to apply them to this idea of a circular motion. So if we come over here and watch, what happens is we have this sphere that goes around and around and around, and it's forced to keep traveling around this thing in a certain amount of time. Okay, so the question becomes, well, how is it accelerating if it's moving in the same speed at all points around that circle? Okay, because used to up until now, we've always said, well, it's now accelerating, so we've said that it's been slowing down or speeding up. Well, it's not slowing down, it's not speeding up. So what is changing here? Okay, for it to be accelerating, it has to have a change in motion. It's not speed, so it has to be direction. Okay, so we take a look at this. In this case, we're dealing with a change in direction constantly, actually. So in every instant in time, it is slowly following around an arc, or it's not moving in the same exact path. If that wasn't the case, the ball would be moving linearly. But since it's moving in a circle, it is constantly changing direction, which means it is constantly accelerating. So anytime you move in a circular path, anytime you must be accelerating by the sheer fact that you're changing direction, okay? Even if your speed is the same. Now, when it comes to this, because the velocity is always tangent to the circular motion around it, and because the force that keeps this thing moving circular is centered in the middle of our circle. So the force always pulls things inward, okay? If that's the case, remember, we always go back to F equals ma, or Newton's second law, that the force or the net force is equal to the mass times the acceleration. So if we have a mass out here and it has a net force acting on it, so that force has to be pulling it inwards, right? Think back to our hammer thrower. Okay, she had to provide the force to spin that thing around in a circle. So the force had to be coming from her, which means the force was constantly being pulled inwards. Well, with inward force, we need to have inward acceleration, okay? Because the force has to be parallel to the acceleration, all right? Which means we have something called centripetal acceleration. The term centripetal means center seeking, okay? So a centripetal acceleration is just an acceleration towards the center of a circle. Okay, we get it because velocity is changing direction and speed is staying constant here. All right. Now we get two equations that come from this idea of centripetal acceleration. The first is the velocity in tangent squared divided by radius. Okay. The second is 4 times pi squared times r times divided by the period squared. And you might think, well, wait a minute here. Why are we getting all these extra things inside of here? What's happening? But if we go back a couple of slides and we show the equation for velocity to the tangent, remember that was 2 pi rt, okay? So if we were to take this equation for velocity to the tangent and we plug it in here, so 2 pi r, 2 pi r divided by t squared, we end up getting 2 squared, which is 4, pi squared, which we see, t squared, which we see all times r. Okay, so we finally get r in the right spot, right? So it's a combination of this equation and the equation for velocity, which is useful because sometimes we know the tangential velocity, we know the linear velocity, and we can just say, oh, we square that divided by radius, we know our acceleration. And sometimes we don't know the velocity, but we might know the radius of our circle, okay? This brings us down to our most fundamental, or our root values, where we know the radius of the circle, we know the period of the circle, we can find the acceleration by knowing 4 and pi squared. Okay? So there are two equations.